BSCS A1 Production.
Today, we will discuss about basic arithmetic operation in number systems. Arithmetic operations such as addition, subtraction, multiplication, and division are carried out in the different radix bases. This arithmetic operation can alternatively be represented by r's complement and r's minus 1 complements. Binary addition and subtraction are carried out in the same way as decimal addition and subtractions. When we do binary additions, we get two outputs, which is sum and carry. Binary addition follows four rules, and these are listed in the table below. We will have two inputs and two outputs. First, 0 plus 0 is equals to 0 and the carry will be 0. 0 plus 1, the sum will be 1 and carry will be 0. 1 plus 0 is 1 and carry will be 0. Next, 1 plus 1 is not equal by 2 because binary system has only two digits, which is 0 and 1. And therefore, 1 plus 1 is the sum will be 0 and we have the carried 1. Example numbers. We have 1010 plus 1100. First, we will have 0 plus 0 is equals to 0. 1 plus 0 is equals to 1. 0 plus 1 is 1. 1 plus 1, the sum will be 0 and carried by 1. The answer will be 10110. We have also example for 3 inputs. We have 110 plus 101 plus 10. First, 0 plus 1 plus 0 is equals to 1. 1 plus 0 plus 1 is 0 and carried by 1. Then 1 plus 1 and plus the carried, the sum will be 1 and we have the carried 1. The answer will be 1101. That's for binary addition. In subtraction, still we have two outputs, the subtract and borrow. There are four rules for binary subtraction. These are given as following below. If 0 minus 0 is equals to 0, the borrow will be 0. 0 minus 1, the subtract will be 0, but we have borrowed by 1. 1 minus 0 is equals to 1 and borrowed by 0. 1 minus 1, the subtract will be 0 and borrow will be 0. For example, we have 1010 minus 110. First, 0 minus 0 is equals to 0. 1 minus 1 is equals to 0. 0 minus 1 cannot be, and we will borrow from the other. Then 1 become to 2. Then 2 minus 1 is equals to 1. Then bring down 0. It is optional. The answer will be 100.
Binary multiplication. When multiplying binary numbers, it is identical with multiplying decimal numbers with a few exceptions. In this case, you only need to memorize the multiplication table of 1, where 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and 1 times 1 is 1. Also, when doing carries during the addition, you divide the sum by 2 instead of 10, put the remainder, and carry 1. For example, if you multiply 110 base 2 by 11 base 2, so you start with 1 times 0 equals 0, 1 times 1 equals 1, 1 times 1 equals 1, and then you do it again with the second digit, and the answer is 10010 base 2. Next is binary division. Binary division problems can be solved using the long division method. Step 1. Compare the divisor with the dividend. If the divisor is larger, place 0 as the quotient, then bring the second bit of the dividend down. If the divisor is smaller, Multiply it with 1 and the result becomes a subtrahend. Then subtract the subtrahend from the minuend to get the remainder. Step 2. Bring down the next number bit from the dividend portion and perform step 1 again. Repeat the same process until the remainder becomes 0 where the whole dividend is divided. So for example, if you divide 011010 by 0101, the answer will be 101.
Octal system has a base of 8 that includes 0, 1, 2, 3, 4, 5, 6, and 7. Octal arithmetic operations are done in the same way as decimal arithmetic operations. The following is an addition table for octal numbers. For example, we have 5, 6, 7 plus 2, 4, 3. 7 plus 3 is equals to 10. Then 6 plus 4 plus the carry 1 is 11. 5 plus 2 plus the carry 1 is 8. This is the wrong step. What we did is the base of 10, which is the decimal. To add octal numbers, we need to translate it into the octal system. We can use the table or we can use these steps. Then 7 plus 3 is equals to 10. Then we need to translate it into the octal system. 10 divided by 8 is equals to 1 with the remainder of 2. Remainder will be automatically here, 2. Then 1 will be carried. 6 plus 4 plus the carried 1 is equals to 11. 11 divided by 8 is equals to 1 with the remainder of 3. Then 5 plus 2 plus the carried 1 is equals to 8. 8 is still not considered as octal numbers, so we need to translate it. 8 divided by 8 is equals to 1 and remainder 0. So 0 and 1. Therefore, 5, 6, 7 plus 2, 4, 3 is equivalent to 1, 0, 3, 2 with a base of 8. Similarly, we may execute octal number subtraction in the same way that we do decimal number. However, you can only borrow the number 7, which is the maximum digit allowed in octal number system. For example, we have 253 minus 167. 3 minus 7 cannot be, so we need to borrow from 5. 5 will become 4, then 3 plus 8 is equals to 11. 11 minus 7 is equivalent to 4. Next, 4 minus 6 cannot be. Then we need to borrow from 2. 2 will become 1. Then 4 plus 8 is equals to 12. Then 12 minus 6 equivalent to 6. Then 1 minus 1 is equals to 0. Therefore, 253 minus 167 is equivalent to 64, the base of 8.
Octal multiplication. Multiplying octal numbers is similar to multiplying decimal, but you need to convert the product into octal every time. If the product exceeds 7, divide the number by 8 and carry the quotient, and the remainder will be taken as the sum. For example, if you multiply 25 base 8 by 16 base 8, 6 times 25 is 176 base 8, and 1 times 25 is equals to 25 base 8, and if you add all that, it will be 446 base 8. And this is the octal multiplication table. Octal division. The rules in octal division is the same, but it's easier to make a table of multiples of the divisor beforehand. So for example, if you divide 6573 base 8 by 16 base 8, you first need to make a table of the multiples of 16 and then do the division. So 6573 base 8 divided by 16 is 366.4 base 8.
Hexadecimal numbers has base of 16 that includes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A, B, C, D, E, F. Arithmetic operation of hexadecimal numbers can be performed using addition table for hexadecimal numbers, which is given as below. For example, ADD plus DAD. We can use the table for the following steps. D is equivalent to 13. So D plus D, 13 plus 13 is equivalent to 26. 26 is not considered as hexadecimal numbers system, so we need to translate it. 26 divided by 16 is equivalent to 1 with the remainder of 10. Remainder of 10 will be directly here. 10 is equivalent to A and with the carried of 1. So D plus A with the carried of 1. So D is 13, A is 10, plus 1 is equivalent to 24. So translate it. 24 divided by 16 is 1 with the remainder of 8. Then 8 and remain carried by 1. A plus D, which is the A is 10, then D is 13, then 10 plus 13 plus the carried 1 is equivalent to 24. Then translate. 24 divided by 16 is 1 with the remainder of 8. So 8 and carried by 1, let's bring down the 1. Therefore, ADD plus DAD is equivalent to 188A with the base of 16. Hexadecimal values can be subtracted utilizing complement techniques or simply as decimal subtraction. The digit borrowed from the immediate higher position is counted as 16 under the rule of basic hexadecimal subtraction. For example, we have 974b minus 587c. b is equivalent to 11, then c is equivalent to 12. b minus c will become 11 minus 12. It will become negative, so we need to borrow from 4. Then 4 will become 3. Then 11 plus 16 is equal to 27. 27 minus 12 is equivalent to 15. 15 is AF. Okay, next 3 minus 7 is cannot be, so we need to borrow again from 7. So 7 will become 6. Then 3 plus 16 is equivalent to 19. Then 19 minus 7 is equivalent to 12, which is C. Next, 6 minus 8 cannot be, so we need to borrow from 9. 9 will become 8. Then 6 plus 16 is equivalent to 22, minus 8 is equivalent to 14, which is E. And lastly, 8 minus 5 is equivalent to 3. Therefore, 974b minus 587c is equivalent to 3ECF with a base of 16.
Hexadecimal multiplication. When multiplying hexadecimal numbers, it is more convenient to use the multiplication table. Just do multiplication like usual, but you need to carry the left digit and make the right one as the sum. For example, 75 times DA. So A times 75 is 492. And D times 75 is 5F1. So 75 times DA is 6382. And here is the hexadecimal multiplication table. Hexadecimal division. The hexadecimal numbers division is the same as the division performed in other number systems. All the rules and principles are the same. Just like in octal division, it is easier to do a table of multiples of the divisor. So in the example, AE 887 base 16 divided by 3A base 16, we make a table of multiples of 3A. So AE 887 divided by 3A is equal to 3025.A3 base 16.
Decimal arithmetic procedures are highly common and more simpler. In various number systems, these operations are carried out in the same way. Basically, decimal arithmetic is the procedure that we use in basic mathematics. And here is the sum of example.